Hi folks, and welcome back to Math with Captain Rod. I'm making this video as a dual purpose video here. Part one, I'm going to talk a little bit about how least squares regression is done. And then second, we're going to talk a little bit about how to find a trend line without using a computer. So first of all, I talk about least squared regression. So the idea here is, we're looking at some sort of data set, and this data set seems to be reasonably correlated. This shows some sort of negative correlation, negative because it's decreasing down to the left. Then the idea here is how to find some sort of linear function to describe it. Now, first of all, why a linear function? Well, this data just looks, honestly, by visual inspection here, like it can be modeled linearly. Now, regression analysis can be done with other types of functions. You can do quadratic regressions, exponential regressions, and so forth. The first step is you usually take a look at your data, just kind of visually inspect it, and you can usually decide what type of curve you're going to want to fit to it. For this example, I'm going to stick to a linear function. Now, the idea here is we want to find the equation for this line here. All right, that's going to look like a y equals mx plus b, and you're looking for an equation that best fits the data. Now, I teach physics, and what I do in physics lab a lot, right, is we actually, we look at the data, and I usually have people just kind of eyeball, right, try to place this line in such a way that it just kind of best describes the data as a whole. Some good properties for that, well, you want about as many points kind of above the line as you do below, and you want them kind of uniformly distributed. How we've got some points above here, here, and so forth, and some below here, some here, and so forth. So this line right here roughly looks about correct. So I'm going to go ahead and draw it. Right. Now the question is, how do we find a function for it? How do we find a y equals mx plus b? So the most common method, and honestly the most accurate, is just use a calculator or a computer. Most calculators have a function that will do linear regression for you. What I want to do here is just, oops, what happened to my line here? There we go. All right, what I want to do is just chat a little bit about what is a calculator doing when you do a regression analysis. So it does what's called a least squares regression. And if I look at this guy, right, for example, right here, there are differences between what the function is going to tell you and actual data points. And if I draw these differences in, I'll draw them in green. They're here, 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 here. These green lines that I'm drawing represent the difference between the function and the actual data points. Okay. The idea behind a least squared regression is that you look at the difference between the function that you come up with and the data points. I'm just going to put minus d for data. This difference is squared, and then this difference needs to be minimized. So basically, I'll just put it like this. The calculator calculates a line that minimizes the sum of all these green differences, the sum of these things, and typically squared. And the reason that it needs to be squared is because some of the differences are positive, some of them are negative. It's very easy to get a sum of 0 and have still very, very, very poor correlation. You typically look at the sum of the differences squared. That makes all of these positive. And what the calculator does is it calculates a line for you that minimizes the sum of these green distances. Right? I'm going to talk a little bit about how you can calculate a regression line by hand, because I think that's a valuable thing to know how to do. Right, so the first step in trying to calculate a regression line by hand is you draw it, again, visually, and I've done that here. Maybe I didn't do a perfect job. In physics, usually in physics lab, we just do, kind of by eyeball here. And there's also other methods that I use in physics to check your regression lines or to check your regression of your functions. But I'm going to start with this. You usually start by just drawing a line that visually looks like it best describes the data. Right? Then it's just a standard algebra problem. Right? Any line should be written y equals mx plus b. And the first thing we need is the slope. So The slope of the line between 2 points we can calculate. Slope is equal to change in y over change in x. So you typically just pick the change in y and change in x's. So the slope in this example, I'm going to go ahead and calculate a value here. I'm going to look at my line, and what you do is you pick 2 points on the line. They do not have to be data points. In fact, most of the time they probably won't. You pick 2 points on the line. You want to typically pick kind of clean points, ones that you can pick off pretty easy. This would be a good one right here. I mean, look at this guy. That point right there is pretty clearly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's the point 115. Oops. I'm going to look for another one here that I know pretty definitively, and I always advise people try to get the other one over here on the right somewhere. Oh, let's see. Let's use this point right here. Right, x values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That looks like the point 14, and then the y value 1, 2, 3, 4, 5, 6, and a little more, maybe 6.5 approximately. All right. So then we'll go ahead and calculate a slope. So y2 minus y1 over x2 minus x1. That was this one. That was a 1. If you give me a moment here, I'm going to calculate a value. I get out of this, let's see, negative 0.654. I'll just take negative 0.65 is good enough. All right, so the slope of this line is around negative 0.65. Next step here is to find b. You can do that a couple ways. One, you can find another point on the line, plug it in for x and y, and calculate b. Or you can just read it right off the graph. So this thing, we look back here. All right, I'm going to count. I guess that was a y value 15. This is a little more than that. Well, maybe it's not 16, maybe 15 point, maybe 7 or 8, something like that. I'm going to call that about 15.7. Just by inspection. All right, so the line here that describes this data looks like it's right around something like this, minus 0.65x plus 15.7. Now, when you do do this by hand like I've done, I have no, I'm not going to go through and calculate an R value, and how the R values are actually calculated are a little bit beyond the scope of what this video was intended. For now, it's enough to just say, well, this one, visually shows a pretty strong linear relationship. Here's how I can get at least a guess at a pretty good function for it. This function should describe this data reasonably well. A calculator, again, if you put in your data points here, would give you a slightly better function, but I think it's pretty handy to be able to calculate one on your own. So that's a little bit about least squares regression and how to find a regression line kind of by hand. I hope that this video demonstrates how to do that for you. Have a great day.